Okay guys, so welcome back again to another video. In this video, we are going to talk about the very important reaction in organic chemistry, especially in organic synthesis, and also if you are following retrosynthesis course, then this reaction would be much important to you. Okay, we are talking about the Diels-Alder reaction. So first, I will tell you what the reaction is. Right? Let's say we have diene like this, and we have an alkene like this. So these two can react together to form a cyclic compound like this. Okay, we will talk about the mechanism now. One thing to notice here is this is concerted reaction, right? Concerted reaction. I hope you know what the meaning of this concerted means, right? Concerted means the bond breaking and bond forming happens simultaneously. Okay, the concerted means that the bond breaking and bond forming is happening simultaneously. Now, when we look at the mechanism, okay, this is what happens. So you can understand this mechanism like this. Just we have three double bonds, we have three pi bonds. Start from one. Okay, so let's start with here. So you have to go in either direction, either clockwise or anti-clockwise. What happens here? Let's go clockwise. So I'm going to rotate like this. So here, look at this. What I'm going to do, I'm going to move this pi bond to here. I'm going to move this pi bond for here. So I'm going to form a new bond between this carbon and this carbon. Okay, and this the pi bond, I'm going to break this pi bond and form a new one between here. You can see this Diels-Alder reaction. This is a like cyclization. You can see that, right? So we can obtain the product. Now you can see we have a single bond between here, this one and this one. We have a double bond between here, and we have a single bond here, single bond here, single bond here, and finally single bond here. We have a cyclic compound. This is the Diels-Alder reaction. So the mechanism is pretty much easy, right? But when it comes to the problems and when it comes to identify the reaction pathways, then we have the tricky part. We will do some quick examples to understand this concept and how we can understand the stereochemistry of this particular reaction. That's the important thing. So most of the cases, most of the questions come with the stereochemistry. So when you identify the stereochemistry, when you have to like mention the stereochemistry, most people get confused. Okay, let's move on for it. So first example, let's look at this reaction. So we are asking, here we have this compound with this. Now we are asking for the product. Okay, you have to write the product. Now let's start this. Look at this. So you can see here we have the two pi bonds, and here we have another pi bond. Now what you have to do is you have to go either direction. Let's move it here, and you have to move this pi bond not here to this particular carbon and this for this particular carbon. Now the stereochemistry is very important, right? Look at how I'm going to draw this. Here we have these two carbons. Like if I number them 1, 2, 3, 4. Here I have drawn the 1, 2, 3, and 4th carbon. You can see now there's another one carbon is attached to this two particular ends, right? I will draw it like this. Okay, this is the, I say, 5th carbon. Now the new part, okay, new part which has added to our molecule, I will draw it in like blue color. Okay, you can see we have bonded it to a new part like this. And don't forget, we have shifted this pi bond to here, so a new pi bond has formed between the second carbon and the third carbon. So this is the product. Okay, this is the product. So be aware when you try to represent the stereochemistry of it. Okay, let's do one another example. So here we have a 6-membered ring carbon with a alkene here. Now I want you to take some time and try to draw the product, right? So if we want to draw the product, let's move on. First I will draw this part. Okay, now you can see we have to start with one pi bond and go cycle. Now we have a double bond here. Okay, we have a double bond here, and here we have the rest of it. Here I have just drawn this one. Okay, 1 2 3 4 5 6. So here we have the 1 2 3 4 5 6. Okay, I hope you got it. Now the thing is this part. Now you have to draw this part. It's pretty much easy, right? You have to draw this one like this. This is the product we have. So these are the let's say these two carbons here. We have these two carbons here. So it's not a big deal, but the tricky part is the identifying of the stereochemistry. Now let's move on to our most important part. Let's say we have a problem like this. Okay, you have to see the product of these two molecules. Okay. What about this now? Okay, let me draw the stereochemistry too, then you can. Okay, what about now? So this is, you can see like this is cis, right? This is on cis formation. Both are in the same direction. So now what would be the product we have here? Okay, what would be the product we have here? No, like you may get it to be so. Let me draw it in another way, which you can easily find out. Okay, now it's fine. Let's go with here. So I can put the trans on this direction. Okay, CO2 ET. Okay, so what about this example? So I want you to think about the product, and also I want you to think about the stereochemistry. Okay, now the drawing the basic ring is easy, right? You can start from one and draw the cycle, and then here you have the product. But this is the product, right? Now we need to indicate these two parts into our cyclic our cis membered ring. Now you can see this is on the cis formation. Okay, this is on the cis formation. So your two CO2 ET groups should be on the same side. So here I have drawn CO2 ET like this. Always remember, right? You have to indicate the stereochemistry, or this one. You can put the CO2 ET groups above the plane like this. Both are okay. Both are okay. Now what if I want you to draw the products for this? So I'm going to add this diene with a trans. Now what would happen? You get the idea, right? Now this is trans, our two groups are on the opposite side. So when it comes to our product, these two cannot be on the same side, because initially you have it on the two different sides. It's a trans molecule. So when you draw the structure for it, you have to draw it like this. One is on a below the plane, and another one is the above the plane. Here we have the product for this particular direction. So stereochemistry is important, right? Stereochemistry is important when you write the answers in your exams. Always remember about the stereochemistry. Don't get confused with it. So this is the trans product. Okay, this is the trans product, and this is the cis product. So I hope you're okay with this Diels-Alder reaction. It's not a big deal, but when it comes to the retrosynthesis and more advanced organic chemistry, this reaction is very important. So if you are following the retrosynthesis course in your university or maybe in your college, we have a separate video list for it. We have done tutorials and we have gave you the basic idea about this retrosynthesis step by step, right? So you can watch it here. I will put the link here, and we have done quite a good amount of questions too. So I hope it will be help you. It will help you. So thank you, and we will get together in our next video.